The MAT 2019 was the hardest paper of the recent years in the MAT, and I'm judging that by the average score of students who got offers to study at Oxford University. This was the only paper in recent years where students had to get, or the average score from students who got offers was less than 70 marks. In all the others, it was above 70. So that's why I'm defining this as difficult, but I'm actually going to show, or hopefully show to you today, that actually it doesn't have to be that difficult. And there are loads of tricks and techniques that can allow you to speed run through the multiple choice questions. And of course, in today's MAT, or this in nowadays MAT, it's mostly multiple choice. So hopefully this works to your advantage. By the way, if you've not seen me before, I'm Jamin. I'm a full-time mathematics tutor who helps students get into Oxford and Cambridge. I myself studied maths at Oxford, so the MAT holds a special place in my heart, and I've obviously been through the same struggle that you're going through. So hopefully I can share some wisdom with you in today's video. Anyway, let's get stuck in. So this is question 1a. The equation x cubed minus 300x equals 3000 has how many real solutions? Straight away we're eliminating a and e because a cubic can't have infinitely many solutions. It can't have 0 real solutions. It has to have at least one. Now, we're looking for the number of real solutions of a cubic. Generally speaking, we want to think about where the turning points are. That's the thing that's going to allow us to determine this. So if I just say let f of x equal x cubed minus 300x minus 3000, we're just essentially working out the roots of this function. To do this, let's find the turning point. So take the derivative, 3x squared minus 300, set this equal to 0. So we have turning points that x is plus or minus 10. And if we just substitute in these numbers, when you plug in minus 10, you get minus 1000. It's not too difficult to work out. And when you plug in 10, you get minus 5000. So if you just have a sketch of this, minus 10 is there, 10 is there. They both have a negative, and they're turning points. And because we know it's a positive cubic, it kind of has to have this up, down, up nature. So it goes up to there and then down there. This thing here is minus 1000. This down here is minus 5000. But crucially, we can see from our sketch, it only has one real solution. The answer is B. Notice that we didn't have to work out what the solution was. Let's look at B. The product of a square number and a cube number is always a square, never a cube, always a cube, never a square, sometimes cube, never square, never cube, or always cubed, always a cube number and always a square. This looks like a weird question. It is a weird question. How do we approach weird questions? We just play around with it. So let's just mess around. The easiest thing we can do is just choose a very simple square and cube number, namely 1 and 1. 1 times 1 is, if I check, it's 1. So we're going to eliminate any options that, because 1 is obviously is a square and a cube. So the answer could be a cube number, so it's not A. It could be a square number, so it's not B. Similarly, it's not D. Amazing. With one kind of example, we've managed to narrow it down options. So from 4 incorrect options left to 1 in just one move. So now we just need to assess whether it's always a cube and always a square, and then it's definitely not, because if we just choose 4 times 1, 4 being our square number, 1 being our cube number, that's 4. 4 is not a cube number, so it can't be E. Thus our answer is C. Question C, the graph of y equals sine squared x plus sine to the 4x plus sine to the 6x and so on equals what? With these questions where you're identifying the graph, I always suggest firstly finding the intercept. So here, what is the y-intercept? You're going to sub in x equals 0. So when x equals 0, clearly y is going to be 0 plus 0 plus 0 plus 0 forever. So it's not going to be A because 0 plus 0 plus 0 is 0. So the y-intercept should be 0. Also, I can kind of easily see here that the graph is, sorry, the y values are non-negative. I'm just adding up non-negative numbers, so it can't be E either. So let's also find the y-intercept. How am I going to do, so the x-intercept, how am I going to do that? I'm going to set y equal to 0. So I get this expression here should be 0. And in fact, this is an infinite geometric sum. And we're going to get sine squared x over 1 minus sine squared x as the sum of this. In fact, this is just true for all values of y. So in particular, when should we have y-intercepts? Well, it's when tan squared x is 0. And so that's at 0, 180, 360, and so on. But annoyingly, all of these options have that. Okay, cool. Now I can play a game of spot the difference. What are the differences between these guys? Well, this guy seems to have difficulties when x is 90 or minus 90. These two don't. But actually, if we see when x is 90, we should have difficulties. And even if we go back to the original definition, if we sub in x equals 90, we can see all these sine terms are just 1. And so we should have that y is infinity. So actually the answer here is D. not C or D. Not B or C, sorry. Cool. Question D. The area between the parabolas with equation y equals x squared plus 2ax and y equals a minus x squared equals 9. What are the possible values of a? Amazing. So we're finding the area between two curves. Remember, the rule is you're going to do the integral of the top curve minus the bottom curve. So here we've got a negative parabola and a positive parabola. So our picture might look something like this, and we're working out that area. So our top curve is going to be the negative parabola, and our bottom curve is going to be the positive parabola. So to work out this area, which is going to be 9, we also need to work out these intercepts here as well. So we're going to do that by setting these two curves equal to each other. So we get x squared plus 2ax plus a equals a minus x squared. And if we cancel out the a's and the 2's, we get that x squared plus ax equals 0. And so factoring out the x, we get x equals 0 or x equals minus a. And so if a is a positive number, minus a will be negative. And so we'll be doing the integral from minus a to 0 of top curve minus bottom curve, which is the negative parabola minus the positive parabola. You can see that this would simplify to minus 2x squared minus 2ax dx. Now this is if a is positive, but if a is negative, then minus a will be bigger than 0, and so we'd be doing the integral from, I'll just write it here, 0 to a, 0 to minus a, sorry, of the same thing. So notice that actually this integral down here is just the negative of this integral. So when you swap limits, that just multiplies the value of the integral by minus 1. So we can just make this integral here equal to plus or minus 9, and then just solve for a. So let's evaluate this. So this is just going to be minus 4 over 3, sorry, minus 2 over 3, sorry, x cubed minus ax squared from 0 to minus a, and we want this to be equal to plus or minus 9. So if I sub in 0, thankfully that's just 0. When I substitute in minus a, just got to be careful here with all the negatives, minus 2/3 minus a cubed minus a times minus a squared equals plus or minus 9. So what do I get? Well, I'm going to get minus 2/3 a cubed plus a cubed equals plus or minus 9. So a cubed, or third a cubed, equals plus or minus 9. So a cubed equals plus or minus 27. Answer A equals plus or minus 3. And the answer therefore is B, like so. Cool. Let's look at E. We'll look at this one. We'll just make this the last one just for time. The graph of sine of y minus sine of x equals cos squared x minus cos squared y is empty, is non-empty but includes no straight lines, includes exactly one straight line, two straight lines, or infinitely many. This looks like an intimidating question. It's actually super straightforward. Obviously, we've got sines and coses, and oh, look, we have cos squareds. So we want to turn them into sine squared, so everything is in terms of sine. And if we do that, we get 1 minus sine squared x minus 1 minus sine squared y, which is just going to be sine squared y minus sine squared x. And if we do the difference of two squares here, which hopefully seems pretty obvious, because if we do that, we get sine y minus sine x, which is what we have on the left. We get, I'll just use s here, sine of y minus sine of x equals sine of y minus sine of x times sine of y plus sine of x. Squeeze that on there. And if I bring everything to one side, I get sine of y minus sine of x, then sine of y plus sine of x minus 1 equals 0. So crucially, either this is true or this is true, but in fact, we just need to look at this. Sine of y being equal to sine of x, that just means that y equals x. Or we could have, sorry, this doesn't imply, but this also includes the lines y equals x, but also the line y equals x plus 2 pi, also the line y equals x plus 4 pi, and so on. So it's going to include infinitely many straight lines, and that's not even including this part here. And so the answer for sure is going to be E. So that is a quick way of kind of speed running through a bunch of different questions in the exam. So with the MAT, remember, most of the multiple choice questions are going to be, you can really aid yourself by doing elimination. So if I'm just scroll through here, Like this question, I eliminated A and E straight away. This question here, I eliminated all the incorrect options just by looking at two different examples. Here again, graph sketching ones for sure you want to do by elimination. This one I didn't really do by elimination. I did have to derive this answer. I mean, potentially if you weren't too sure, you could test some of these values. So test A equals 1, test A equals 3 or minus 3, whatever. And similarly here for this one, I didn't really do this by elimination. This one was pretty straightforward. Once you spot that y equals x and y equals x plus 2 pi and so on would work. In fact, you can maybe spot that straight away. If there is a solution with a line, you can just translate it by a vector 0, 2 pi, and that would still work. Anyway, that concludes this video. I just wanted to illustrate that with the MAT, there are normally loads and loads of tricks and techniques. If you are planning to do the MAT next week, I wish you the best of luck. Also, if you're doing the MAT, or even if you're not, you're probably preparing for your Oxbridge interview as well. That's something I'm helping students with. I've got an Oxbridge interview preparation program starting from next weekend, so the weekend right after the MAT, because preparation needs to start early if you genuinely want to do well and get into Oxbridge. Last year, I had 13 students, 12 of them got offers from Oxford and Cambridge. So if that's something you're interested in replicating this year, let me know. I'll leave a link in the description below where you can book in a call with me and we can see if this interview preparation program would be a good fit for you. Anyway, I'll leave another video on the screen where I give you some advice for the interview and what you can be doing between now and the interview to give you the best shot of getting an offer.